Bismillahirrahmanirrahim. I am Professor Jamil and you are watching YouTube channel. Today we are going to solve a question, an important exam question on Laplace transform, and this question is a kind of two-in-one question. One question will give you two ideas of solution to the question. So let's write. First write the question. The statement of the question is very simple. Here you go. Compute Laplace transform of t into sine of t to the power, let's say 5. Right? Compute Laplace transform of t into sine t power 5. Now, answer or solution to this problem, you need to compute Laplace transform L bracket symbol t for sine of 5t and this. Now if you look, this is Laplace transform of t to the power n into ft, right? Let's write down as let's change the sentence. It is mean this question is of the form, this form, Laplace transform of t to the power n into f of t, and you know this relation is -1 to the power n into nth derivative with respect to the new variable. Old variable is t and the new variable is s. Nth derivative with of the Laplace transform of ft, right? So this implies Laplace transform of t into sine t power 4. Now n is 1 and ft is your sine t with exponent 4. So substitute -1 power 1 d1 by ds1 into Laplace transform of sine 4t, sine 5t. Okay, it's sine 5t. Now Laplace transform of t into sine t power 5, and it is equal to minus 1 to the power d by ds of Laplace transform of sine t, and you may express it as whole power 5. You may name it equation number 1. Here is an important point. You have remembered, or you know already, the Laplace transform of sine t, sine kt in fact, but here you need its fifth power. In the usual way, people try some trigonometric identities and hit and trial methods to solve it. Here I will give you the general method, and the method is which you should look very carefully. You know this sine t as sine theta in fact is e to the power I theta minus I theta. This is definition of sine function in terms of exponentials. So in place of theta you have t, therefore Laplace transform of t sine t power 5 is equal to minus d by ds Laplace transform of, write a definition of sine t in terms of the exponentials. So it is e to the power I theta minus e to the power minus I theta over 2 I theta, and whole power is 5. I told you in the beginning of this lecture that this is a two-in-one question. It could be that compute Laplace transform of sine power 5t, sine t power 5, right? So if this, then these steps will not be required. You will go direct onto this one. This is also an important question. Only that you need to find the Laplace transform of sine t with exponent 5. So this is a 2-in-1 question. It is covering the question of this general type as well as any exponent of the trigonometric function, any integer exponent of the trigonometric function. Integer exponent here is 5, and it could be 6, it could be 3, it could be 10. The procedure will be same as I am outlining and describing here in fact. So now you may do one step and then I will tell you what to do next. Laplace transform of t sine t with exponent 5 equal minus d by ds Laplace transform of, this is 1 over 2I to the power 5 and e I theta minus e minus I theta power 5, and using linearity of the operator L, this constant can be taken out here in front of the operator L. So Laplace transform is t sine t is equal to minus d by ds into 1 over 2I power 5 and Laplace transform of e to the power I in play here you have t, not theta. Here also you have t, not theta. Right? So this is it minus e to the power minus it and exponent of 5. Now you may name it as equation number 2 and check using this this one is like a minus b with power 5, so you can use binomial formula, and binomial formula contains some coefficients which can be obtained from the Pascal's triangle. Here you have 5 exponent, so you will use the Pascal triangle 1 1 1 2 1 1, sum of these, then sum of these, and more 1, sum of these 4, sum of these 6, sum of these 4, and 1, now more 1, sum of these two is 5, these two is 10, these two is 10, and these two is 5 and 1. Now you have reached 5, right? So when you will use the binomial expansion, then the coefficients will be appearing in this form, right? And binomial expansion is as I am going to use now. So let's use equation 2 gives Laplace transform of t into sine t with exponent 5 equal minus, you can take this constant out from the derivative because derivative is with respect to x. So minus 1 over 2I with exponent 5 d by ds and the Laplace transform of now this is a minus b. The first coefficient is 1 and a is e to the power it. Its power will be 5, and the b, apart from minus sign, I need b. b is e to the power minus it, and its power is 0. This is the first term in the binomial expansion. Then since there is a minus sign, you will get alternating plus and minus. Just as first sign is plus, then the second sign will be minus, and the second coefficient is 5. So it is 5, and one power of A will be reduced. So it is 4, and one power of B will be increased. So it is 1, right? So after second you have third coefficient, so minus, and the next one will be plus 10 into the exponent of A will be decreased by 1 further, so it is e to the power it 3 into the exponent of B, means second, this will be increased by 1 minus it, and power is 2. So the next coefficient after 10 is also 10. So after plus you have minus 10 into e to the power it, one power less, so it is 2, and into the power of B will be increased by 1, so it is 3. Oh, now after 5 you have after 10 you have 5 and minus, and you have now plus 5 into e to the power it exponent 1 and e to the power minus it and exponent 4. Now after 5 you have the last coefficient, which is 1, and it will be minus 1 and e to the power it 0 and into e to the power minus it exponent 5. So you have binomial expansion of this term, a minus b. A is e to the power minus it and b is e to the power minus it, right? So you should use binomial expansion even if here you have exponent 10. If the exponent is 10, you will write the Pascal triangle up to this digit 10, right? Now you have done this. Now you understand. You have exponentials everywhere, and you know that transform of the Laplace transform of the exponential. So let's first simplify this a bit. So Laplace transform of t into sine of phi t is equal to, this is minus 1 over 2i phi d by ds into Laplace transform of, this one is e to the power 5it, e to the power, this and exponent 0 mean 1, this is 1, okay, this is 1, minus 5 into, this is e to the power 4it, and the next one is e to the power minus it, this one, and plus 10, this is e to the power 3it, and this is e to the power minus 2it, minus 10, and e to the power 2it, and e to the power minus 3it, and plus 5, and this is e to the power it, power 1, and this is e to the power minus 4it, and in the last you have minus 1, this e power 0 means 1, and into this is e to the power minus 5it, e to the power minus 5it, and curly bracket closed. So one more step, Laplace transform of t into sine t power 5 is equal to minus 1 over 2i power 5 d by ds of the Laplace transform of, this is e to the power 5it minus 5 e to the power 3it. If bases are same, then the exponents are added. So by adding these two, 4 minus 1 makes 3. Now this plus 10 into e to the power 3 minus 2 will make 1. So it is 1 it, mean 2i t. This is minus 10, and e to the power now minus it. Minus 3 plus 2 will make minus it, plus 5 into e to the power minus 3it, minus 4 plus 1. And next, no one here, minus e to the power minus 5it. Now look, this and this can be combined together. Minus 1 over 2i into d is power 5, d over ds, Laplace transform of e to the power 5it and minus e to the power minus 5it. It again goes into the definition of sine theta, right? So we are rearranging so that we get back the definition of sine function now. Similarly, from 3it, this and this, you have 5 common, minus 5 in fact common, and you will have e to the power 3it, and this is minus e to the power minus 3it. This will give you the definition of sine function. Now, for the 10, you have plus 10 common, and it is e to the power it minus e to the power minus it, right? The exponential with positive exponent has been written first because this is requirement of the definition of sine function. Now, if you look carefully, if there is 2i like red, then this is definition of sine 5t. Now, when divided by 2i, it will be multiplied with 2i. So here, similarly, this one, if this is divided by green 2i, right, then this is the definition of sine 3t. But when you divide by 2i, you need to when you divide by 2i, then you need to multiply with 2i. Similarly here, you have blue 2i in the downside to make it a definition of sine t, and when you divide by 2i, you need to multiply by 2i. So by using the definitions of sine function, you have again, look, 2i and 2i, it is out, so minus 1 over 2i power 5 d by ds into Laplace transform of 2i. Okay, write that 2i, this is sine 5t minus this is 5, and this is sine of 3t, then 2i, and this is plus 10 into sine of t and into 2i. Now you can take 2i out using linearity property of the Laplace operator. So using linearity, correct spellings for linearity of operator L, we get, let's see what we get. On the left, there is as usual t into sine of t to the power 5 equal to minus 1 over 2i 5 exponent d by ds, and now 2i is out. So 2i into Laplace transform of sine 5t minus 5 sine 3t plus 10 and sine of t. As I told you earlier, we were expecting that since there are exponentials and we can use the Laplace transform of the exponentials. But during the course of simplification, we had an opportunity of checking that we do not need Laplace transforms for the exponentials individually, because exponentials can be recombined into sinusoidal functions, means sine functions. And you know the Laplace transform of the sine kt as well. So let's use, but this 2i out, you need to use linearity once more, because this linear transform operator L will apply on this function, and this function, and constants will be taken in front. So using linearity of L again, you can use its linearity property again, and 2i, this can be taken in front of dy ds because it is constant with respect to x. And next, be careful, d by ds of Laplace transform of sine 5t minus constant out, and Laplace transform of sine 3t plus this constant in front of L, and Laplace transform of sine of t. Right? Now, using Laplace transform of sine kt, this is equal to k divided by s square and plus k square, right? Where condition is that s is greater than k. Now use this for your Laplace transforms of the sine functions in this step, and you get, this will give you minus 1 over 2i to the power 4 and d by ds, and into, this will give you k is 5 here, k is 5, so 5 over s square plus 5 square minus 5 into sine 3t would mean the k is 3 now, this is your k, right? So this is 3 over s square plus 3 square, and for this piece you have k equal to 1, so it is 1 over s square plus 1 square and bracket closed. This step. Now you can simplify it a bit further. Minus 1 over, this is 2 to the power 4, and I to the power 4 is I square and I square, and that is minus 1 minus 1, and it makes plus 1. I will write in the next step. And d by ds, here you can take LCM of all these, mean s square plus 5 square, s square plus 3 square, and s square plus 1 square. This is 5 into s square plus 9. You can simplify 3 into s square plus 1 minus 5 3s are 15 into s square plus 3 square out, and this s square plus 25 into s square plus 1 plus 10. This will be left, and here you have these two factors, s square plus 25 into s square plus 9 and bracket closed. Now minus minus plus, so this is minus 1 over 2 to the power 4 and d by ds of this. Look, here you can take 5 common, right? 5 is common, and it can be written out here. 5 is out. So d by ds. You can expand these two. S square plus 10s plus 9. Right? Look. S into s square into s square will be s4, and the constants will be added to give this term, and then the constants will be multiplied, right? Minus, you have 3. 5 has been taken out, so 5 3s are 15, here 3. And here you have s4 plus 26 s square plus 25, right? The constants will be first added, then in the end they are multiplied. Similarly here 5 and out, then you have here 2 into s4. Now constants will be first added to make 34 s square, then they will be multiplied, and 25 multiplied by 9 will be 225, and this bracket closed. Now you need further simplification. This is minus 5 over 2 to the power 4 d by ds, and here look, this is s4 plus 10. S4 can be collected together. S4 here minus 3s4 and plus 2s4. Now it's the term for s square. Plus 10s square. Here you have minus 6 3s are 18. 6 3s are 18. 3 2s are 6 plus 1 7 s square. And next it is 68 s square. Now it's turn for the constant terms. Plus 9, and it is minus 75. 25 multiplied by 3, and now this is plus, it is 450 multiplied by 2. Look, this term is 0. It's 2 plus 1 3 and minus 3. This goes all together, and this is 68 plus 10 78 and minus 78. This also goes out entirely, right? And you are left with the simple constant. What it will be? 450 plus 9 will be 459, and minus 75, and it will be 9 minus 5 4, and 15 minus 7 will be 8, and here you have 3. So it is 384. 384. Okay. It's 384. So Laplace transform of t into sine t power 5, it is equal to minus 5, and this constant can also be taken out, and it is 384 divided by 2 to the power 4, 2 to the 4, 4 to the 8, 8 3 is 16. So 2 to the 4 is 16. And d by ds of what you have? Yes, there was something in the denominator which I left. So let's write the denominator, and you can write the denominator here. 1 over s square plus 5 square, s square plus 3 square, and s square plus 1 square, right? And the same denominator here, multiplied, and you can write it as s square plus 25, s square plus 9, and s square plus 1. And here you have 1 over s square plus 25 into s square plus 9 into s square plus 1. And before taking the derivative, you can also expand it. 16, can we simplify? Think 384 divided by 16, d by ds, and you can expand it. 1 over First these two. S4 plus 25 plus 9, 34 S square and plus 225 into S square plus 1. Right? And in the next step, 16 1 2s are 32, 6 makes a 64 and 16 4s are 64, so it is minus 120 and d by ds, here you have 1 over, this is s6 plus s4, then this multiplied 34 s square plus, oh sorry, 34 s4 plus 34 s square plus 225 s square plus 225 and some little steps are, in fact very few steps are required to get finalize the answer. Now you have 1 over s6 s4, this will make 35 s4 and now s square, this and this red, how much? 5 plus 4 is 9, 2 plus 3 5 and 2, it's 259 s square and then the constant 225. Now you need to take its derivative and you will take derivative by using power rule of differentiation, which is minus 120 and this is minus 1 over square for the denominator first. Square into derivative of the denominator and this derivative will be 6s5 plus 140 s cube, this 4 will come down and 35 multiplied by 4 is 7, 140 and this is 2 comes down means 9 2s are 18, 5 2s are 10 plus 1 18, sorry 9 2s are 18, 8 1 carry, 5 plus 5 into 2 makes 10 plus 1 11, 1 carry, 2 2s are 4 plus 1 is 5 s square and the derivative of this will make 0. Now, good. So, you have your final answer now and it is Laplace transform of t to the power sine t with exponent 5 equal to minus 120 into, you can take s square common from here and it will be written as s square into, this is 6 6, you can also take 2 in fact out from here. Okay, I take 2 also out. 2s square is out. So you have 2 3s are 6 and then s cube plus 70 into s and plus, here you have 2 2s are 4, 1 carry, 2 5s are 10 and 2 9s are 18 and s square has been taken out. Look, and in the denominator you have s6 plus 35 s4 plus 259 s square plus 225 whole square. I guess we cannot factorize this, or we can, I don't know, but this is enough. This is 240, and let's check, can we make a factorization of the above? Because in the downside we know this everything is a can be factorized into 3 factors, which we already simplified here. And if we can make a factorization in the above, it would be fine. 3. Okay, leave it as such. So Laplace transform of t into sine t power 5 equal, this is minus 240 s square into 3s cube, s cube 65, and this is, yes, okay, 3s cube plus 70s plus 259 divided by, this can be written as s square plus 5 square, s square plus 3 square, and s square plus 1 square. These were the factors which we simplified in the denominator to get this one. And you can write them again, right? And because of this square, you will have square here, and square here, right? And that's it. This is the Laplace transform of t sine to the power 5t. Thanks for watching. Keep watching, and please like, share and subscribe this channel with your friends and family, so that every interesting and some meaningful question comes into your inbox first. Thanks.